now looking at proof. You will have to do a proof on Thursday. This is the proof you're going to have to do. If you're actually looking in the textbook, it's on page 517. But I want to give an outline of the proof so that you can put this together in a reasonable, organized, reason, two-column proof. So let's draw a little sketch and see what's given. We're given a point outside a circle and two tangent segments. So these are drawn to the circle, touching in one spot. If you were to continue this, that would be a tangent line. These are tangent segments, so we don't care about the entire line, just the two segments. And what's given in this is a result from the circles chapter that tangents will always be perpendicular to the radius drawn at the point of tangent. So you can go back and look at theorems 59 and 60. I don't need you to know those. Those will be given, that the two tangent segments are perpendicular to the radius. So I'm telling you that is a right angle. Your task now is to use that information. It does give you a hint. There's going to be some congruent triangles. And you've got to prove that the two tangent segments are the same. That this and this have got to be the same. Okay, so same. Now, how do we go about doing that? Well, let's think of our two-column proof. We have some statements and a reason. So whenever you say something, you have to have a reason that it's true. The first statement would be the given. Let's go ahead and label this. In fact, I think I may actually give you a picture that's already labeled. Let's suppose this point out here is P, and these 2 points are A and B, and we'll use C for the center of the circle. Okay, so you have points A, B, C, A and B on the circle, C is the center, and point P, which is your tangent, the point from which the tangent segments are drawn. Okay, so the first thing would be that AP is perpendicular to CA, and BP is also perpendicular to CB, and those are given. Okay, so that would be the first way that you would draw or set up this proof. The statement that the tangent segments are perpendicular to the radius drawn to the point of tangency. And you should mark the picture. It probably won't be marked, but you should immediately put in the little square. Okay, now the hint says you have to have congruent triangles. So we would go ahead and draw this line CP. So draw CP, and then now the reason, you might want to go all the way back to chapter 1 or 2. What do these 2 points have to do with that line? So see if you can come up with a reasonable, it is a postulate, by the way. You don't have to quote the name of the postulate, just what it says. 2 points do something with that line. Okay, now we do have these 2 triangles, so let's sort of pin down what we know on the triangle. You should know that AC is the same as BC. I'll mark that. AC and BC are the same. And why might that be? It has something to do with the radii of circles. So see if you can complete that. We also know that CP is equal to itself. CP is equal to itself. That's sort of a duh. There's a reason why things are equal to itself. Make sure you find that reason. That's also going to be a postulate or an axiom early in the book. Anything is equal to itself. What's that called? Okay, and let's see if we can make this a little bit smaller so I can. I'm going to be running out of work here. Let me grab a page. Okay, number 5. We're going to have to say the triangle is congruent to the triangle. Now, remember, when you're giving reasons for congruent triangles, you have 5 choices: side, angle, side, angle, side, angle, side, 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 angle, angle, side, and hypotenuse leg. One of these 5 must be this reason. And if you go back and look at the picture, you'll see, let's see, We have a side and a side, so that would claim it has to be either this one or possibly this one. We don't have any information about angles, so that's out. Now notice in this one we require the third side. That's not true. That's what we're trying to prove. Remember, we're trying to prove that this third side is in fact equal to this side. That's what we have to prove. So we don't know that yet. So that says we can't use side, side, side. So it has to be either side, angle side, or hypotenuse leg. And if you know something about the angle, we had an I word back in the earlier review. You know, what kind of angle is that? And then look at the sketch, and you should realize that this reason that these two triangles are congruent will have to be the last remaining possibility. Now, when you do write the letters for the triangles being congruent, make sure you get them in the right order. So the first one, you can use any letters that you want. If I did A, P, C, that's okay. But then for the second triangle, I have to make sure I get these letters, you know, what corresponds with A? Well, that would be B, right? What corresponds with P? And I hope that you could see that. And so, yeah, these letters have got to be in the right order. Again, the reason you can say that, one of the 5 choices. And then the very last line of your proof would be the fact that AP is in fact going to be the same as BP. Notice that here's AP, here's BP, right? And so those are corresponding parts, and these triangles are congruent. So hopefully you'll have that last reason, corresponding parts, and I'll let you finish the rest of that. Okay, so not a hard proof. It does tie together congruent triangles, which is a big deal in Euclidean geometry, and circles, which is sort of the last couple of chapters we've covered. Okay, so hopefully you can work that proof cleanly tomorrow.